is bisected by the meteorology boom, as you see here. And there's some other Viking spacecraft parts in the foreground. And behind it is Mars. And you can see a large boulder, you can see other rocks, and you can see lovely sand dunes behind. It looks like many places on the Earth. The governor of Nevada once told me that he knew a place in Nevada that looked exactly like this. And you can almost imagine a sort of grizzled prospector pulling his mule along, coming out from behind one of those sand dunes. But no grizzled prospector was found. Here is a close-up of these sand dunes, and it's quite amazing how similar they are to the sand dunes on the Earth, say in the Sahara or the Mojave deserts, despite the fact that the particle sizes, the wind velocity, the atmospheric pressure are all extremely different on Mars. There's a great deal to learn about deserts from studying Mars. And now here is another color photograph, again bisected by the meteorology boom. You can see now color photographs of the sand dunes towards the horizon. And now here is quite a pretty picture showing in a different direction, away from the sand dunes, the field of rocks and boulders. Notice how the boulders in middle distance are dark colored, quite different from the boulders in foreground. If we look now at the next photograph of Mars, we see a close-up of a rock to the right, which we originally called Big Bertha, but there was a complaint from a women's liberation group, quite properly we thought, and so it is now called Big Joe, and no one has complained. Big Joe is so large that had we landed on it, we would have been destroyed. Viking 1 would have been destroyed. And is an indication that it is not terribly easy to land on Mars. Now here is a field of strewn rocks lying before the spacecraft. You can see it's very hard, rocky ground. But if we take a close-up look in this scene, we see that behind many of these rocks are tails of sand, raised, elongated streaks of sand, all pointing in the same direction. And this is very similar to the situation we talked about in the last lecture, in which there were such streaks behind craters. And the situation is just the same. In fact, we found that the direction that all of these streaks point is the same as the direction that big streaks point in this same region. These are wind markers from the last great dust storm in this region. And they point in the direction that the wind blew. Now, things do change on Mars. Here is a photograph of Big Joe. And here's Big Joe. And here is a small rock. And you can see that between this small rock and Big Joe, there is no rock. But now, if we dissolve to a picture taken just a little bit later, we see that suddenly there has appeared another rock in an intermediate position. And that rock, here we are going back to the original. And now we dissolve to what it looked like later. Now, that is a change which has occurred in a small scale in a short period of time on Mars. Either the wind has uncovered that rock, or the sand has slid off the rock because of a small Mars quake or something of that sort. There are Mars quakes. One was detected by the seismometer on Viking 2. Now, we put on top of the Viking lander a kind of grid, which you can see here, a kind of checkerboard, to show the positions of things we dumped there. And then we had the sample arm reach out, acquire some Martian surface material, and like an elephant washing itself with sand, dump the sand on its back. And here is what that looked like. Here you can see the same grid now all discolored with the sand. And we watched this, and as time went on, the sand moved, gradually blowing in this direction and in this direction, gradually accumulating against this device. Now, this is the first close-up investigation of the motion of fine particles on another world. And we have found that not only does this occur, but we have found what wind velocities are necessary when it does occur, and very high winds are required, as we had suspected long before. Now, all of this discussion so far has been about the Viking 1 lander, and I'd like to talk just a little bit about Viking 2. Here again, we wanted to land in a safe place, and we were running out of time because in November of 1976, Mars was passing from the Earth's vantage point behind the Sun, and we were not sure that we would be able to reacquire the Viking landers after that solar occultation event. So we wanted to put Viking 2 down on Mars and get some preliminary information before November. On the other hand, once we had Viking 2 in orbit about Mars and looked at the region we were in, we found some extremely strange terrain which we did not understand, and again we were worried that we would crash the spacecraft as we landed. So, for example, one strange place that we saw was this region, which you can see here in the lower left seems to be covered with giant fingerprints. You see all these ridges that are in parallel and curved. The ridges are about 1 kilometer across, so it's an extremely large fingerprint. And since there are craters on top of the fingerprints, this one, for example, these are extremely old fingerprints. They are, of course, not fingerprints, but what they are, we don't know. And if we don't know, we must not land there. So we moved on to a different longitude in the same latitude, and we came upon ground like this, in which there are roughly polygonal patterns covering the landscape for tens and hundreds of kilometers. Such things are known in the small, in the Arctic regions of the Earth, but never at this scale. Again, we had to be extremely cautious and not land here. Eventually, we found a place which looked sort of all right. There wasn't anything too bad, or at least too puzzling near it. We sat down and landed successfully, but we were lucky. Here is the first photograph from the Viking 2 site. The Viking 2 landing place was called by the old astronomers Utopia. So in case you've wondered what Utopia looks like, this is it. Here is the lander footpad, and you can see it's covered with Martian surface material, which was obviously thrown up in a great cloud as we landed. Here is a rock which we think we turned over in the process of landing. We did land on a rock, and in fact we were tilted 7 degrees for the rest of the mission. And here is a rock which is vesicular. It's full of holes. And whether that's because of sand blown by wind eating out the surface material, or whether this is a kind of rock produced by volcanic events, we don't know. But it is a kind of rock we never saw in Viking 1. Now, when we step back and look towards the horizon, again, that's the meteorology boom you've seen before off to the left. There are, you may think, strong similarities between this scene and the Viking 1 scene. That's certainly right in that there are rocks extending out to the horizon. There are also a number of differences. One of those differences is the existence of this trench or furrow, which you can see runs straight across the picture. And in fact, when we map all of those furrows in all directions around us, they seem to also make a kind of polygonal pattern. We seem to be on patterned ground, and perhaps that is due to permafrost, as in the terrestrial Arctic, but perhaps not. There are also no sand dunes in this region. That's another difference. If we take a close-up look at the trench, here it is up here, we can see in it a pyramidal-shaped rock, and whoops, there it is, pyramidal-shaped rock, and also a sheer face of a rock that seems to have recently been cut by what, we're not sure. Well, this is an extremely quick look at the Viking 2 landing place. In fact, both Viking landers are still all right, and both Viking orbiters are sending information back. We have acquired an enormous amount of information about Mars. and